Hello guys and welcome to another video from Tech AWW, and today we will be looking at the Arduino UNO Q, the most controversial, I at least would say the most controversial SBC single board computer ever released. And we will be looking both at the device itself and the app that comes with it. So welcome and let's begin. Now, the first downside is you can't actually use the app without connecting the Arduino UNO Q, which doesn't really make sense to me, but maybe there's some reason behind it, I don't know. So basically how the Arduino UNO Q works is there are multiple chips. The Qualcomm Dragonwing, which is the computer, and then there is the microcontroller. Because the whole Arduino UNO Q, the idea behind it is that the computer and the microcontroller can communicate together. So for example, you can handle a database on the computer and then, I don't know, put sensors on the microcontroller, something like that. So once you open the app, there are some examples, but we are not really going to be checking those out because you can do that on your own if you buy the board. So the first thing I want to show is the structure of the script for this SBC, because it's very different from a normal microcontroller. As you can see, if you open, for example, bridge test, which I created to test out a feature I will also be talking about in this video, there's always a UNO file sketch, just like in the Arduino IDE, but there's also a Python file. Because how the structure of this works is first you send the Python file to the computer, where it then runs, but also the computer has a special software that makes it so it flashes the sketch that you also send to it on the microcontroller. So you can't manually flash, at least not that I know of anyway, to actually flash it just on the microcontroller without using the firmware from Arduino to use the computer side to flash it on the microcontroller side. So that's why there is always a Python file and a sketch. Obviously you don't have to put anything in the Python file if you only want to use the microcontroller, but then it kind of loses the whole point of it being an SBC, so then you can just buy an Arduino UNO. The sketch is programmed in C++, so just like the normal Arduino sketches, and this is in Python. And now the main feature that I actually was testing here, it's called bridge test, and the feature is the bridge. So as you can see, there is multiple things here. It's bridge call, and in the sketch side, there is bridge provide, which is the most crucial functions on this SBC. So basically how it communicates is that the USB pins on the computer are connected with the RX and TX communication pins on the microcontroller. So basically it's just like when your laptop or computer is communicating with a normal microcontroller. So that's why it can flash sketches and send serial data. So how it works is first you must import the utilities, Arduino app utilities, which is also the bridge, and then you can use the command bridge.call and enter a message. When this triggers, the message will be sent over the data lines to the microcontroller side. So then you need to do bridge begin, which will begin the bridge communication on the microcontroller side, and then do bridge provide and the message. That works the way that when this appears on the bridge, so for here it's set underscore led underscore state, it does something. For here it calls a function, and the function turns on or off the built-in LED. So as you can see, if you click run, which installs everything, both the sketch and the Python file, just give it a moment. So as you can see, the LED starts blinking, and that's because here in the main Pi, there's always a 500 milliseconds delay in the loop, and then it calls set let state into the bridge, which the microcontroller side receives and calls the function set let state, which switches the state of bool current and then writes that to the let built-in. So that's why it's flashing. For a better example, we can actually here look at servo with UI, which is the second example I've prepared for today. So as you can see for this is a basic web UI that I actually used from the example. So this just has a button, and as you can see right here, bridge call set LED state LED is on. So it sends this over the bridge with this variable, LED is on. So when the sketch receives it, it needs the message set LED state, which calls the function set LED state, which then reads the variable, which is a bool state, and if it's true, then it writes the servo to 60, and if it's false, it writes it to 120. So as you can see, if we run it, just give it a second. Now it was flashed and a window opens, which is the localhost 7000, which leads to the page of the Arduino. And as you can see, if I press the button, now just don't mind it says LED, as I said, it's from the example, so I didn't really edit it. But as you can see, when I click it, it turns the servo accordingly. So basically this is kind of the framework of it, and I would say the main two reasons why I would say this is actually a really good idea is, first of all, because of AI, right? Because if you want, for example, local AI image recognition to, for example, drive a robot, you can't really have that on an ESP32 or an Arduino Uno because it's really slow. Well, I mean, you can have it, but it's so slow as hell. Or you can have it on just an SBC, which is a single board computer, like a Raspberry Pi. But then again, it is pretty hard to program. While with this, you can use some of the examples and just use C++ if you already know how to program that, and just program it in a normal microcontroller like you used to. Now, the second reason why I think it's a pretty good idea is for databases. Because, for example, if you want a database or an interactable website, where there either is a lot of data streaming in, or there's a lot of user requests, an ESP32 on Arduino with a Wi-Fi module usually fails if there's just too many requests. Like when I was hosting my server on an ESP32 microcontroller, it was already slow with just one person browsing it. While this can hold a pretty stable website and actually send the data to a microcontroller, it can, for example, have sensor detect to it, so either the microcontroller sends data from the sensors to the computer, or, for example, you can have a robot controlled from a website and multiple people can control it at once or something like that, I don't know. But I would say that is pretty good idea. Now, the last feature, if you just don't want to upload apps or just want to do something else on the Linux side, because this is running Linux, you can actually open its command prompt. So this makes it so your computer's command prompt connects to the Arduino's command prompt. And on the command prompt you can do normal commands, so you can just use it, for example, to install local AI, or I don't know, you can control the computer through it. You can just use normal Linux commands to control it, not just uploading apps and Python files. So yes, that pretty much concludes it for today, and I hope to see you next time. So I hope you enjoyed this video, and I hope you brought something new to you, and goodbye.